Hello everybody, welcome into another lesson. So today we're going to talk about modeling with quadratic equations. And what this really is you're going to be given some parabolas with certain characteristics and you got to find the equation. So we're going to find the equation in standard form of the given parabola. So we have a parabola with a vertex at 2, -2, and it passes through the point 0, 2. Well, what are some helpful things to remember? The equation for a parabola, of course, in this case, if you're given the vertex, if you are given the vertex, I'm definitely going to recommend that you write the vertex form. The vertex form for a parabola, of course, is y equals a times the quantity of x minus h squared plus k. Well, that x minus h, that's the factor for the x coordinate of the vertex, because if you set x equal to h, you'll get the x coordinate of the vertex. And then the k is the y coordinate of the vertex. So hk is your vertex. And then it passes through random point 0, 2. What we really need to do here to start with is solve for a. And then we have a hope at getting this into a standard form. So in this case, we have y is equal to a times OK. The h, your x coordinate is 2. So this would end up being x minus 2 quantity squared, because if you set x minus 2 equal to 0, you'll get the x coordinate of your vertex at 2. Plus your k, well, your k is -2. So this is going to be y equals a times the quantity of x minus 2 squared minus 2. Now, you set up the foundation for your equation. What you have to do next, this random point 0, 2 that it passes through, you'll substitute the x value of 0 in for x, and you'll substitute the y value of 2 in for y. So you'll end up having 2 is equal to a times the quantity of that x of 0 minus 2, that quantity squared, minus 2. Which means 2 would equal a times, what is -2 squared? That'd be positive 4, so 2 equals 4a minus 2, which means 4a equals 4, so a equals 1. All right, so we've solved for our, we have solved for the scale factor outside of the coordinate of the x coordinate of the vertex being 1. So the scale factor is 1. Now let's come back to our equation here. So we're going to have y would equal, that a is 1, so we don't even need to put anything there. We'll just have straight up x minus 2, that quantity squared, then minus 2, because the original goal was to solve for your a. Now we have a hope of getting this into standard form. So here is the vertex form of the parabola. Now we just want to get this in standard form. All you're going to have to do is expand this x minus 2 to the second power. That would give you x squared minus 4x plus 4, all that minus 2. And then you'll end up getting y equals x squared minus 4x plus 2. And that would be your final result. It's in the form y equals ax squared plus bx plus c. You have the equation in standard form. So y would equal x squared minus 4x plus 2. And I got more examples of this here. I got like 3 examples of each here. I got 3 examples of each type we're going to do today. Alright, what if, let's see, this time we have a vertex would be located at -1, 4. So here's the vertex at -1, 4, passing through the point -2, 2. And then it just goes down something like that. We don't even need to know intercepts, but what we do know is the vertex is at -1, 4. It passes through the point -2, 2. Alright, so the parabola has a vertex at -1, 4. It passes through the point -2, 2. How are we going to find the equation? Well, again, since you are given the vertex, write the standard form of the equation in vertex form to start with. So y would equal a times the quantity of x minus h squared plus k, right? That's the standard form of a parabola in vertex form. That's a quadratic equation in vertex form. Now, the next goal, again, is we're going to find... we want to find a. So start with y equals a times x minus, okay, what is your x coordinate of the vertex? It's -1, so x minus -1 would actually be x plus 1. That quantity raised to the second power, then your k is +4, so this would be +4. So we're off to the start with y equals a times the quantity of x plus 1 squared plus 4. Now this point it passes through -2, 2, so that -2 will stand in for x in this equation. That +2 will stand in for y. So substitute those in and you can solve for a. So 2 equals a times the quantity of -2 plus 1, that quantity squared plus 4. So then you'll have 2 equals, okay, -2 plus 1 is what? -1, that quantity squared is 1. You'll end up having 2 equals a plus 4, which would give you a being equal to -2. So your coefficient, your scale factor is -2. That's your coefficient, is -2. So once you found your a, come over here, put that a in for the vertex form of the equation. So you would have y would equal that -2 for your a times your x plus 1 being the x coordinate of the vertex, that quantity squared plus 4. So now we just have to expand all this out and distribute, and then we should be able to get the equation in standard form from here. So let's see, y would equal -2 times, let's expand this out, x plus 1 squared is x squared plus 2x plus 1, all that plus 4. So y would equal -2x squared minus 4x minus 2 plus 4, giving you your final equation in standard form would be y equals -2x squared minus 4x plus 2. So the equation for this parabola in standard form would be y equals -2x squared minus 4x plus 2. I got one more like this, and then we're going to move on to intercept forms and find an equation in standard form. right. Let's redraw this a little bit here. So let's see, we have another parabola. This time vertex is located at 1, 0. It's at 1, 0. Passing through the point -1, -3. So if you're just given a vertex and a point it passes through, you don't really care about intercepts. The vertex is located at the point 1, 0. Then it passes through the point -1, -3. All right, so again, what you in general need to do, go ahead, write out the general form for the vertex form of a quadratic equation. So that'd be y equals a times your quantity of x minus h squared plus k. That's the vertex form for a parabola in a quadratic equation. Now, let's do this particular case where the vertex is at 1, 0. So you would have y equals a times the quantity of x minus, what's the x coordinate of your vertex? 1. So that'd be x minus 1, that quantity squared. Now the y coordinate of the vertex is at 0, so we don't have to put anything for k. We literally just have y equals a times the quantity of x minus 1 squared. Now, for the point it passes through, take your x coordinate of -1, put that in for x, and take your y coordinate of -3, put that in for y. So you'll get -3 equals a times the quantity of -1 minus 1, that quantity squared. So -3 would equal a times your -2 squared. Well, what is -2 squared? That's positive 4. So you would get 4a equals -3, which means a would equal -3/4. So now we found our a, we found our coefficient to be -3/4, okay? So let's come over here. Let's put this in for the general form for this equation for a vertex. For the vertex form, y is going to equal that a of -3/4 times the quantity of x minus 1 squared, because 1 is the x coordinate of your vertex and 0 is the y coordinate of your vertex, so we don't have to add anything. So here's the vertex form for the equation of this parabola. Now let's expand this out to get the standard form. So y would equal -3/4 times the quantity of this x minus 1 squared is x squared minus 2x plus 1. So for the final form, for the standard form, y would equal -3/4 x squared plus 3/2 x minus 3/4. So this is the equation for this parabola in standard form. Y would equal -3/4 x squared plus 3/2 x minus 3/4. So that's how, if you're ever given the vertex and a point the parabola passes through, that's how you're going to find the equation for the parabola in standard form. Now let's move on to 3 examples of another type. And then there's one more type after that. All right, now what if we have this one? So this is different. We have an x-intercept at 3, 0. We have another x-intercept at negative 3, 0. So you're given two x-intercepts, and then this parabola passes through the point 1, negative 4. So these next three examples, you'll be given x-intercepts, and it'll pass through the point 1, negative 4. If you're ever given intercepts in a point it passes through, we need to find the quadratic equation in intercept form to start with before we can go to standard form. The intercept form, if we remember, is y is equal to that a times the quantity of x minus p times the quantity of x minus q. In general, this is the intercept form of a quadratic equation. It's some coefficient times x minus your first intercept times x minus your second intercept. Well, in this particular case, it's going to be y equals a times the quantity of x minus your first intercept at negative 3. X minus negative 3 would actually be x plus 3 times the quantity of the second intercept is at positive 3, so that'd be x minus 3. And if you set each of these factors equal to 0, you would get x equals negative 3 and x equals positive 3 for your intercepts. So literally take x minus the value of your intercept. X minus minus 3, you get x plus 3, and then x minus 3, you get x minus 3. Well, much like with the other types, once you've got it into intercept form this time, that value, that 1, negative 4 it passes through, you're going to plug in that value of 1 for x, and then you're going to plug in that value of negative 4 for your y. So plug in the negative 4 for y. That's going to equal a times your x value of 1 plus 3 times your x value of 1 minus 3. The goal is still the same to start with, solve for your a. This would give you negative 4 equals a times, let's see, what's 1 plus 3? That's 4. 1 minus 3 is what? That's negative 2. So what you really get is negative 8a equals negative 4, which is going to give you an a value of positive 1/2. So now we got the coefficient to be 1/2. So it's important to start out trying to find that coefficient. Now, let's come over here. Since we know the value of that coefficient now, y in this case would equal that a value of 1/2 times your two factors of x plus 3 times the quantity of x minus 3. Of course, we want to get to standard form. Good news is, though, we can FOIL this out, which will give you the difference of two squares. Y would equal 1/2 times the quantity of x squared minus 9. So the final equation in standard form would be y equals 1/2 x squared minus 9/2. That would be this quadratic equation and the equation for this parabola in standard form. Y equals 1/2 x squared minus 9/2. And I got two more like this. So in this form, we care about the intercepts but not the vertex, unlike the last type we did where it's the opposite, where we cared about the vertex and not the intercepts. Well, this time it's opposite. Okay. What do we have now? We have a parabola with intercepts at -2, 0 and +1, 0. it's not a vertex. Alright, so we have another parabola here. This time you got x-intercepts at -2, 0, and then at +1, 0. And it passes through the point -1, -6. So this parabola in particular, x-intercepts at -2, 0 and +1, 0, passing through the point -1, -6. What are we going to do then? Well, once again, write the equation for a quadratic equation in intercept form. If you're given intercepts, work with that. So y would equal a times the quantity of x minus p times the quantity of x minus q, right? That's the standard intercept form for a quadratic equation. So think of it this way. If you're given a vertex, use the vertex form to start. If you're given intercepts, use the intercept form to start. Alright, well, in this case, we want to start with these are particular x-intercepts. So y is going to equal a times x minus your first x-intercept. Your first x-intercept is at -2. So x minus -2 would actually be x plus 2 times the quantity of your next one. Your second x-intercept would be x minus your other intercept of 1, so x minus 1. So y equals a times the quantity of x plus 2 times x minus 1. Now, this point of -1, -6 it passes through, we got to deal with that. That -1 will go in for x, that -6 will go in for y. So -6 equals a times -1 plus 2 times -1 minus 1. Alright, so -6 is going to equal a times 1 times -2, which would mean that -2a is equal to -6, giving you a coefficient for a of 3. So a would equal 3. Now that we found our a, let's come over here, so you'll get y equals that 3 times your two factors of x plus 2 times the quantity of x minus 1. First, before you deal with that 3, FOIL the x plus 2 and x minus 1. So y would equal 3 times the quantity of, let's see, this will be x squared minus x plus 2x. That'd be plus x minus 2. So this would turn into y equals 3x squared plus 3x minus 6. So that would be the equation for this parabola in standard form. Y equals 3x squared plus 3x minus 6. And I got one more like this, and then we'll move on to the last form. Alright, let's do the last one where we have x-intercepts, and then we're going to move on to the final type. So we are given a parabola with x-intercepts at 0, 0, as well as at 4, 0, passing through the point 3, 3. Alright, so we have x-intercepts at 0, 0, and then again at 4, 0, and it passes through the point 3, 3. It passes through 3, 3, alright? So x-intercept 0, 0, 4, 0, passing through the point 3, 3. Since we're given intercepts, use the intercept form of a quadratic equation to start. So y would equal that a times the quantity of your x minus p times the quantity of x minus q, which in this case then, let's make it specific to this case. So y would equal a times x. Okay, so a times x minus your first intercept. Your first intercept is at 0, so x minus 0 times the quantity of x minus your second x-intercept, which should be at 4. X minus 0 times x minus 4. Which could simplify into y equals ax times the quantity of x minus 4. That's going to make your life a little bit easier, because x minus 0 is just x, right? Now we need to deal with this 3, 3 that the parabola passes through. So for x you'll substitute in 3, and for y you'll substitute in 3. So 3 equals a times 3 times the quantity of 3 minus 4. Well, that would give you 3 equals a times 3 times negative 1, which would have to mean that negative 3a would have to equal 3, so a equals negative 1. So your coefficient is negative 1, and that makes sense since this parabola is upside down. Now, come back to your intercept form here. In this case, y would equal, the a is negative 1, so just good old negative x times x minus 4. And then just distribute, you'll get your standard form. Y would equal negative x squared plus 4x. And that would be the equation for this parabola in standard form. Y equals negative x squared plus 4x. Now there is one more type where this time we don't know intercepts, we don't know vertices, but we're given 3 points that the parabola passes through. And we have to get the equation into standard form. Good news is we don't have to graph it this time, because what's going to be replaced with is a wonderful system of equations. I'll show you how that works. So, let's say it passes through, this parabola passes through what? What points? Negative 1, 5, 0, 3, and then there's one more point, 3, 9. So the parabola passes through the points negative 1, 5, 0, 3, 3, 9. How in the heck are we going to do that? What is the standard equation of the standard form of a parabola? It's y simply equals ax squared plus bx plus c, right? If you're only given points and no x-intercepts or vertices, you can go right to standard form. Here's how it's going to work. For each of these, okay, so for each of these points, you're going to take, for example, negative 1, 5, you'll take the negative 1, put that in for x, and then take your 5, put it in for y. So you would end up with, let's see, 5 is equal to a times your negative 1 squared plus b times negative 1 plus c. So basically what you're going to end up getting here, and I'll write this off to the side, is a minus b plus c equals 5. We're going to actually end up forming a system of equations. Now do the same with your 0, 3. So you have 0, 3. So 3 goes in for y, 0 for x. So you'll get 3 equals a times 0 plus b times 0, well 0 squared, which is still 0, plus c. What do you literally get? You'll literally get that c is equal to 3. That's a dead giveaway. There's a substitution. Now, what about the last one? 3, 9. So that y is 9. That's going to equal what? Then a times your x squared, which would be 3 squared, plus b times your x of 3 plus c. So 9 would equal 9a plus 3b plus c. So what you end up having here is 9a plus 3b plus c is equal to 9. So now you see what you got. You have a 3-variable system of equations. You need to solve this system of equations to find your values for a, b, and c. Well, c is 3. We can substitute that in. Let's substitute that into these two equations. You'll drop down to a system of 2 equations. So this would look like a minus b plus that 3, because c is 3, would equal 5. And then 9a plus 3b plus 3 would equal 9. So this is going to turn into what? A minus b equals 2. And then 9a plus 3b would end up equaling 6. Well, before we try to do any elimination or any tricks, what do we notice? The 9a plus 3b equals 6, don't they all have common factors of 3? So sure, we can divide this by 3. You'll end up having a minus b equals 2. Divide the second equation by 3, you would get 3a plus b equals 2. Now what do you have for both of these? You have a negative b and a b. You can actually add the two equations together and eliminate the b term. You would simply end up getting 4a equals 4. Which means what? That a equals 1. Now, we already know a and c. Take both of your a and c values and substitute it into any one of these other equations and solve for b. So a is 1. 1 minus b plus 3 equals 5. So that would have to mean 4 minus b equals 5, which would have to mean negative b equals 1, so b would have to equal negative 1. So we found a to be 1, b negative 1, and then c 3. So all you're going to do now that you've solved the system, take all those values, put them in for a, b, and c, and you'll have your equation in standard form. So y would equal, that 1 times x squared is just x squared. B is negative 1, so you have x squared minus x, and then that c is 3 plus 3. So you literally end up getting y equals x squared minus x plus 3 for this particular parabola. So this one can be a bit of a doozy because you have to use systems of equations, but it is a viable method. Let's do the next one here. I got two more, then we're done. All right, let's see. Passing through the points 1, 2, 3, 4. And then what's the third point? 6, -8. So this parabola passes through the points 1, 2, 3, 4, and then 6, -8. Again, we don't know any x-intercepts. We don't know any vertices. If none of those are present, just go straight to writing the equation in standard form. Y equals ax squared plus bx plus c. So now, go ahead, take each of your coordinates, the 1, 2, so put the 2 in for y. That's going to equal a times your x squared of, that'd be 1 squared, plus b times your x of 1 plus c. Well, what this would give you is 2 equals a plus b plus c. So you literally get a plus b plus c is equal to 2. All right. Now take your next point, the 3, 4, put in 4 for y. That's going to equal a times your x squared of 3 squared plus b times your x coordinate of 3 plus c. So you would get 4 equals 9a plus 3b plus c. So you would end up then getting 9a plus 3b plus c is equal to 4. So there's two of your equations. Now let's do your final point. You'll end up with, you have the point 6, -8, so -8 would go in for y. That's going to equal a times your x coordinate of 6 squared plus b times your x coordinate of 6 plus a c. So this would become -8 equals 36a plus 6b plus c. So you would end up literally getting 36a plus 6b plus c is equal to -8. So there are your system of three equations we need to solve. Well, we can definitely use elimination to drop this down to two variable systems of equations and then do elimination again. So what do you say? Let's do that here. So if I take a plus b plus c equal to 2, and then I take 9a plus 3b plus c equal to 4, I can subtract the second equation from the first. I'll end up getting rid of the c. I'll end up getting -8a minus 2b equals -2. So -8a minus 2b equals -2. And then let's deal with the second equation. So I'll deal with the first and third. If I take a plus b plus c, set that equal to 2, and then I have 36a plus 6b plus c equals -8. Well, likewise, I can subtract the second equation from the first and then get rid of c. I'll end up with -35a minus 5b rather, would equal 10. So notice I've done two equations where I was able to eliminate the c variable. So let's put these two new equations together. You'll get -a minus 2b equals -2. You'll get -35a minus 5b equals 10. Well, let's look at the first equation. Can't you divide it by 2? You could certainly divide it by 2. You could divide everything by 2. You'll end up getting negative 4a minus b equals negative 1. You could divide everything in the second equation by negative 5. That would end up giving you 7a plus b would equal negative 2. Now look at this. Look at the b term. I have a negative b in the first equation, a positive b in the second, so all I got to do is add these two equations. I'll eliminate the b variable and be at a. So that means negative 4a plus 7a, that would be 3a. Negative b plus b is 0, but negative 1 minus 2 is what? Negative 3. That's going to give me an a value of negative 1. So I found my a being negative 1. Now, all I have to do is take a, put it into either one of these two equations, and then solve for b. I'll take the negative 4a minus b. So negative 4 times negative 1 minus b equals negative 1. So 4 minus b equals negative 1. Negative b equals negative 5. Well, that means b just equals 5. So we got a at negative 1, b at 5. Now just pick any of these original three equations and solve for c. I think it's obvious we want to go with the top one, right? So a is negative 1, so you'll have negative 1 plus your b of 5 plus c is equal to 2. Well, that would give you c plus 4 equals 2, giving you a c value of negative 2. So we found a, b, and c. All we have to do now is take those, put them into the standard form. So a is negative 1. That means y would just equal so far negative x squared plus that bx. The b is 5, so negative x squared plus 5x plus your c of negative 2. So what you end up with in the end is y equals negative x squared plus 5x minus 2. And I got one more like this, then we are done. I know these systems are a bit of a doozy, but that's how they're done when all you're given are 3 points that they pass through. All right, let's find the last one here. So some of these are, well, I think I found the best one. Negative 3, 4. Negative 1, 0. And 9, negative 10. Hideous. So we got negative 3, 4, negative 1, 0, and 9, negative 10 that these that this parabola passes through. So yeah, some of you are probably screaming, wait, you got an x-intercept. That's true, we only have one. We only got one x-intercept. You need to have two of them, or the vertex, in order to use the other forms. This form you can technically use on any of them. You could technically use for any of them as far as whether we've had the vertex or the intercepts. You can do this method for any of them, but I don't recommend it for the other two because then you're doing more work than you need to. What we're doing now is a last resort. That's if you only know 3 points it passes through. So let's go ahead here. What we're going to do now is set up our next three equations. So you would just end up getting here. So take your negative 3, 4. Y goes in for 4 goes in for y. So 4 equals a times that x squared, which would be negative 3 squared, plus b times your negative 3 plus a c. So that means 4 would equal 9a minus 3b plus c. So now we have our first equation here, 9a minus 3b plus c would equal 4. So there's your first one. Now let's do your second one. That's going to be with the point negative 1, 0. So that 0 goes in for y, so you'll end up getting 0 equals a times your x of negative 1 to the second power plus b times negative 1 plus c. So this means a minus b plus c is equal to 0. So put that in. A minus b plus c is equal to 0. And then we'll do the final point. This one's going to be hideous. So let's do our point 9, negative 10. Well, negative 10 will go in for y. That's going to equal a times your x value of 9 to the second power plus b times your x value of 9 plus c. What this is going to give you is negative 10 equals 81a plus 9b plus c. So this will give you your third equation of 81a plus 9b plus c equals negative 10. Not looking pretty, is it? But that's the nature of the beast when all you get are 3 points that this passes through. So let's go ahead now, try to go from 3 variables down to 2. I think it's obvious we want to try to eliminate the c variable to start with. So take your 9a minus your 3b plus c equal to 4. Then take your a minus your b plus c equal to 0. You can subtract the second equation from the first. You'll get rid of your c. You'll end up with 8a minus 2b would end up equaling 4. So there's one. Now deal with, I'm going to say let's deal with the second and third equation here. Take your a minus b plus c equal to 0, and then your 81a plus 9b plus c equal to negative 10. Subtract your second equation from the first, you'll end up with negative 80a minus 10b, the c goes away, would end up equaling positive 10. So then we're down to 2 variables now. So you'll take 8a minus 2b equals 4. Then the negative 80a minus 10b equals 10. Alright, so what do we got here? In the first equation, you notice you can divide everything by 2, right? If you do that, you'll end up with 4a minus b equals 2. 4a minus b equals 2. In your second equation, you can divide everything by negative 10. You would end up getting positive 8a plus b would equal negative 1. So we've simplified this. Now all you got to do is add these 2 equations together. You can get rid of the b variable. So add these 2 equations. 4a plus 8a is 12a. The b's go away, and then you would just get 1 on the right hand side. So a is going to equal 1/12. Not a pretty number. Now take that a of 1/12, put it into any of these other equations here. So why don't we take 4 times that 1/12 minus b equal to 2. So this would end up giving you 1/3 minus b would end up equaling 6/3. Negative b would end up equaling 5/3. So that means b would end up equaling negative 5/3. Alright, so we've got our a of 1/12, b of negative 5/3. Now all we got to do is take these two values, put it into one of these equations, and solve for c. I'm going to go with a minus b plus c equals 0. So let's put in 1/12 minus negative 5/3. That'd actually be plus 5/3 plus c equals 0. Well, 1/12 plus 5/3, that's going to be the same as 1/12 plus 20/3. I'm sorry, 20/12 plus c equals 0. Well, 21/12 is what? Those both divide by 3. That would give you 7/4. So c would end up equaling negative 7/4. So now we found our a, b, and c. Just put them all into the standard form for a quadratic equation. You'll get y equals that a of 1/12. So y equals 1/12 x squared minus 5/3 x minus 7/4. Yeah, that was a doozy, but we sure did do it. So y equals 1/12 x squared minus 5/3 x minus 7/4. That would be the answer for this equation in standard form. So that's it for this lesson. That's actually it for Quadratic Equations unit. Next lesson, we're going to start the Polynomials unit. The very next lesson should be easy, more like a review from Algebra 1, where we'll just review properties of exponents. So I hope everyone has a great night. Take care.